6-3 in college algebra. You should have a big old packet in your hand. We will not do all of this packet for practice. I'm going to skip around and do ones that I feel we need to do, and then your homework will be to finish the rest of them, right? So we'll do actually less than half of these problems, right? So just pay attention to where I start from and which number I'm on, because we're going to go all over the place, right? So on the front side, starting with number 2, they say divide these by using synthetic division. Once you see synthetic division, again, you'll be like, oh yeah, that's how to do it. You know, it just takes a little bit to remember. The question is, what do you divide by? When they want to take this polynomial right now, divided by x plus 3, you need to synthetically divide by what makes that 0. Right? We synthetically divide by the zeros. So since this is x plus 3, what value of x will make that turn out to be 0? Negative 3. So we'll synthetically divide by negative 3. Then you'll put this little bracket type thing. What goes up top here is the coefficients of all of these guys in order with all placeholders. So since this is a third degree polynomial, the first coefficient is 2. Then you need the second degree guy, which is a 3. The first degree is a negative 4. And then the 0th degree is 15. Real simple way to realize if you have all of the coefficients is if this is third degree, there better be 4 terms because the constant term needs to be counted also. So there better be 4 guys represented. Sometimes you got to throw those zeros in because there wasn't any x squareds in there or something like that. So to synthetically divide, first move is whatever that dude is, he comes down. So you bring the 2 down. Then you multiply negative 3 times 2, which is a negative 6. You put that in this spot right here. Then add these together. 3 plus a negative 6 is a negative 3. Then you just do the process over again. Multiply. Negative 3 times negative 3, 9. Add them up. Get a 5. Multiply. Negative 3 times 5 is negative 15. And this is the spot where your remainder will be. And in this case, 15 plus a negative 15 is 0. Right? So this remainder turned out to be 0. They want to know what was the quotient. That's all of these guys right here. And you have to realize what you just did was you knocked it down an entire degree. This was a cubic, so if you go down 1 degree, it will become a quadratic, like a second power degree. So these are all the coefficients of that. Our quotient is 2x squared minus 3x plus 5. This is the x squared right here. These are the x's, and this is the constant terms right there. Our remainder in this case was 0. Right? So there's our remainder. Cool? When you are doing problems like this, the remainder will not always turn out to be 0. What we'll do in a few problems is that's where we wanted the remainder to be 0 because we're finding the roots of all these polynomials. These, they'll just say, please divide, right? So the remainder could be whatever. So let's jump down to number 4. Moving straight down. What should we synthetically divide by? Negative 2. And then this is a quadratic, so you'll got your squared, your first power, and your constant. Right? If that's a second degree, there better be 3 dudes in there, which there are. So we bring the first guy down, multiply, multiply. And in this case, you get a remainder of negative 4. So since this was a second degree, then this guy's got to be a first degree. This is 1x minus 8. Right? This is x, and this is your constant term right here. And the remainder was negative 4. What we just basically proved was that negative 2 is not a 0 of this graph right here. If we cross the parabola, it will cross the x-axis, maybe 2 places, maybe 1 place, maybe no places. I can tell you where it doesn't cross it at. It doesn't cross it at negative 2 because negative 2, we would have got a remainder of 0 if it would have been a root. We didn't get a remainder of 0. So next one is 6, straight down. Synthetically dividing by 3. Whatever makes him 0. So 1, 3, negative 3. There should be 3 guys in there since that's a second degree. Always 1 more. The question is now, this would be a parabola if we graphed it. Is 3 a 0 of this puppy? Yes or no? No, the remainder was not 0. The remainder was 15. So if you get a remainder of 0, then that's where that puppy crosses the x-axis at. Yes? 8. On the next page. What should we synthetically divide by if that says x minus 4? Whatever makes him 0, which would be a positive 4. This is a third degree polynomial, meaning I better have 4 guys in here for coefficients. Watch your signs also. That's the negative versions of them as well. First rule, the biggest mistake is the first guy comes down. I always put that arrow there to help me realize he's got to come down. Then you start doing the multiplier. So then you get negative 20 like that. Add those up and you get a 6. And you get a 24. Should get a remainder of 0 on this situation. What goes in this quotient blank then if this is a 2, a minus 5, and a 6? What degree will I be in if we started with a third degree? Second degree. So this would be 2x squared minus 5x plus 6, remainder of 0. If we graph this cubic right here, it would cross the x-axis at x equals 4, right? 4 is a 0 of this puppy because the remainder turned out to be 0. You cool with just doing division? Okay, let's jump over to the next page and start with number 13. Finding the exact zeros of a polynomial. It will come into play finally, you know. Many of you have never seen it before. It's like, what's the point? Well, eventually, not today, but this unit, we will realize what's the point of finding all these zeros. First of all, the number of degree that you will have will be the number of zeros there'll be. They could be rational, they could be imaginary, whatever. So what degree is this puppy right here? This is a third degree, so put yourself 3 blanks right here. There will be 3 zeros that we will find. What we need is we need to find one of them for sure. So what we've done in the past, and there is a way to figure out if you didn't have a graphing calculator. We'll learn that today also. It's like, what would you do if you didn't have a graphing calculator? It's like, how would you do this? It's not fun, but since we do have a graphing calculator, let's grab our graphing calculator and let's graph this. So that's y equals x cubed plus 4x squared plus x minus 6. Correct? I have them all typed in here, so that way you don't have to sit and wait for me today. I took the liberty of punching them in, and it will only graph the ones with the black boxes by it. But would you believe it's x cubed plus 4x squared plus x minus 6, correct? And I want you to graph him, just zoom 6 him. We are looking for a rational root, all right? We are looking for a rational root. So what happens is if the roots are irrational, they always come in conjugate pairs. If the roots are imaginary, aka complex, they always come in conjugate pairs. When you graph that, does it look like that's at a nice, neat place right there? Like, where would you feel that that is if you were to take a wild guess? That x equals what? -3? Let's check to see if it is. Hit trace -3. If you hit trace -3, if y comes out to be 0, then that's a 0. Did you get a 0 right there? Boom, there's a rational answer. Let's try another one. That one looks like it could be possibly -2, right? So trace -2. We did get y equals 0, hot dogs. And now here's what this tells me, just kind of previewing ahead, is I know that this third root has to be rational. It cannot be irrational, meaning like the square root of 2 or one of those real nasty ones, because irrational roots always come in conjugate pairs. You get 2 at a time, like the square root of 2 and the negative square root of 2. So I know that he's got to be rational. Looks like he's at 1, and he was at 1. Thank you, Mr. Graphing Calculator. He found all my roots for me. Cool. Let's jump to 14, which is the next problem, and let's graph him. First of all, how many zeros are possible? There are how many? 3. Whatever degree you are, that's how many zeros there are. So let's graph him. And you just zoom 6 in it, and you're looking for rational roots. I know it's hard to see on my little calculator right there, but this guy right here, I can tell, is not rational. It's probably between 0 and 1, 0 and -1, right? So I don't suspect him to be my first rational root. It could be, I just don't know yet. But over here, does it look like any of those places might be rational? At 3, so I'm going to try that. Trace 3. And boom, there's a root right there because you got 0 back. So I definitely know that. But you know, people get confused the word rational and whole numbers all the time. They're like, well, I know that's not on a whole number, so it's probably not rational. You could have like a 1/2 or a 5/8 or something like that. So you really need to check before you go ahead and do all this synthetic division to see if these are rational or irrational. So what I got is I also got y equals 0 graphed. So go to your graph and also have y equals 0 on there. And I want to intersect those. So, my bad. Second, calculate intersection. First curve is y2 for me. Second curve is y4. I'm going to guess. I want to see if this guy comes out rational or not. Sorry, I hit the button too many times. And all I'm looking for is a repeating decimal. Does that decimal repeat? Does it have a pattern to it, like 0.6666666 or 0.16161616? Not repeating, so that tells me I got an irrational answer. Meaning, if I have one irrational answer, you have to get 2 of them, right? Irrational answers come in pairs. So I know this is the only rational root that I have. So how do I find the others? I do synthetic division to find them. And this is the case where you actually synthetically divide by this number because you're dividing by the zeros. That's what we did before. We divided by what number made them 0. 3 is a 0 to this, so let's synthetically divide this polynomial by 3. And I know that my answers won't come out nice. They're supposed to be irrational. If that's a 3rd degree polynomial, I better have 4 dudes inside of there. I don't know why I put the pluses. So I do have the 4 dudes inside of there. Let's synthetically divide, and you better get 0 for a remainder this time because 3 is a root. When you divide by something you know is a root, the remainder has to be 0. So multiply, -2, -6, -1, -3. Good news for me, right? This is good. This is now a quadratic expression. This is x squared minus 2x minus 1 right there. We want to know when it equals 0, so you can set it equal to 0. And your job is to solve this for x. You've got, in my opinion, 3 ways to solve it. You could factor it, you could use the quadratic formula, or you could complete the square. Let's rule out factoring right now. How do I know that these won't factor? What kind of answers are we supposed to get, rational or irrational? Irrational. None of these will factor then when those are irrational. The only things that factor are rational solutions. So you could either use the quadratic formula, which if you want to use it, or you could complete the square. It doesn't matter to me. You're free to do whatever you want. A is 1 and B is even. What do you think I would choose to do? I would complete the square when A is 1 and B is even. So what that means is I'm going to get this, all the x's on one side and all the constants on the other side. So x squared minus 2x plus blank equals 1 plus blank. It has been a while since we've completed the square, but you keep all your x squareds over meow, and you move your constants over. How do you fill in the blank? Half your b value squared. What's half the b value squared? It's going to be -1 squared, which is a positive 1. 1 goes in each blank. Now, this guy factors to a perfect square trinomial. This number right here is half your b value every single time. All right, what was half the b value? -1. All right, so there he is. And what do you got left on this side? If I switch to a pen, what's 1 plus 1? 2. That tells me I'm going to get irrational answers because that's not a perfect square. Then you square root both sides. You don't have to put the radicals if you don't want to, but the square and the square root cancel each other out. And you get plus or minus 2. That's the most important part. You will get two answers, the square root of 2 plus or minus 2. Then if you solve for x, you would add 1 to both sides. X equals 1 plus or minus the square root of 2. Sorry, I didn't put the square root symbol around that. 1 plus or minus the square root of 2. Here's your two roots, 1 plus the square root of 2, 1 minus the square root of 2. And I'm telling you, if you'd have done the quadratic formula, you'd have got the same thing, right? I don't care which one you use. If you want to use the quadratic formula, use it, right? If you don't like completing the square, use the quadratic formula. You will still get 1 plus or minus the square root of 2 when you use it, whatever floats your boat. But if A is 1 and B is even, I'm telling you, this is faster if you know how to do it. So yay for that. There's our three roots. Next one, how many possible roots? We're on 15, by the way, 15. How many possible roots are there? 4. Boom, 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 boom. You can graph him much faster than I can. When you zoom 6 him, it looks like this guy and this guy look to be rational roots. So trace them. Just double check. I don't have this punched in. You can do it for me. 1, 2, 3, 4. Isn't that negative 4? Trace negative 4. Is he a 0? Yes. The other guy over here was 4. You trace him. Yes. So it doesn't mean that these are irrational or not. It means I got 2 left. So you could second intersect, see if that's a rational number, right, with your y equals 0. Because that'll save you a lot of time than having to do the synthetic division stuff. So second intersect, do you get a repeating decimal in that situation? Or a terminating decimal, like 2.5, you know? No, so that means they're irrational. It's time to do a little synthetic division. You have to synthetically divide 2 different times. First time by this 0, second time by that 0. It doesn't matter which order you do them in. I just do them in the order that they're listed. So the first thing I'm going to synthetically divide by is negative 4. I take him and synthetically divide him. 1. There are no x cubes. There are negative 21x squared. There are no x to the first, and there are 80 constants. Since that was a 4th degree polynomial, there better be 5 numbers in here. It gets tricky. Also, if you don't get a remainder of 0, something went wrong. You probably were missing a 0 up here. You better get a remainder of 0 every time you do this. The other mistake is people accidentally put negative 4 right here. They put the arrow down, but they accidentally put negative 4 just because they're thinking ahead of what they're writing, right? Whatever that guy is comes down. When you do this, though, this was a 4th degree polynomial. All this stuff now is a 3rd degree polynomial. The only thing that we can solve that we are really good at is 2nd degree polynomials, quadratics. So we've already synthetically divided by him and knocked him down to a cubic. It's time to now just do the process over again. We will now synthetically divide by the positive 4, and we'll knock that cubic down to a quadratic, which we can solve. So, starting over, remember using the different 0 now. 1 comes down, and you go through the whole process again. Wait a minute, something went wrong here. 1 comes down. Yeah, this is a plus 20, thanks. Okay, so then negative 20, 0. So that was a positive 20. I made a sign error on that. Nice. Now, this right here is a quadratic because there's only 3 terms. This is x squared plus no x's minus 5, right? This is x squared plus 0 x's minus 5. Nice. I want to know when it equals 0. I like this one. due to the fact that there's no x to the first, you don't have to do the quadratic formula on it. You don't have to complete the square. Get x squared all by himself. X squared equals 5. So then how do you get solve for x? Square root x equals plus or minus the square root of 5. Notice they come in conjugate pairs. You get the positive square root of 5 and you get the negative square root of 5. Your irrational roots always come in pairs, and they are conjugates of each other. Different signs. Fun, 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 fun. Let's try 16. We'll do this whole page, by the way. 16. Graph him. Find your rational roots. I'll let you punch that in. This is what he looks like when you graph him. There should be 4 zeros because there's a 4th degree polynomial. Looks like that's nice at -1. You need to check it. Trust me, you'll need to check it. Trace -1. It comes out to be a 0, correct? And does 2 work for a 0 also? Yes. There's 2 left. That's good, right? There should be an even amount left. You don't see any other places either. Take a wild guess what kind of roots they should be then. They should be imaginary. Is there any multiplicity going on? Is this root have multiplicity? Does he cross the x-axis or touch the x-axis? He crosses it, so no multiplicity. Same thing here. He crosses. There's no multiplicity either. So I'm looking for 2 imaginary roots. I'm glad that there's 2 because they have to come in pairs. So we synthetically divide by whatever root you want to first. That's why you did that, so you have something to synthetically divide by. 1x to the 4th. There's some x cubes. There's some x squared. X. There should be 5 guys in there, which there are. One comes down. Plus 8 is 25, right? Negative 25, negative 26. You better get a remainder of 0. Otherwise, you made a mistake. Now, if you chose to use the 2 instead of the -1, you'll have different numbers than me, but whatever, right? This is now a cubic. You've got to synthetically divide again by the other root. You don't change the sign on these roots. You do on what we did before, because those weren't roots, they were polynomials. You had to find the root. So that would be 2, -6, -12, 13, 26, 0. Sweet. I want to make sure everyone's with me. This is x squared minus 6x plus 13. And you want to know where it equals 0. You're trying to find the roots. You got 2 choices now. You know it won't factor because they're irrational. You know it's also going to come out nasty and imaginary. You could complete the square. You could use the quadratic formula. A is 1, B is even. I personally am going to complete the square. So x squared minus 6x plus blank equals, what comes over here is a negative 13 plus blank. Half my b value squared is how much? Negative 3 squared is 9. That's good, right? I'm supposed to get a negative answer over here because I know it's coming out imaginary. It's this part that we messed up with, and I understand we haven't done a lot of complete the square in your past. Square root of this guy, x. Square root of this guy, 3. Bring that sign down. This number is always half your b value if you've completed the square correctly. And that equals negative 13 plus 4, plus 9 is negative 4, right? So now this, you square root both sides, and you'd get x minus 3 equals, what's the square root of negative 4? Don't forget plus or minus. 2i, right? Because 4 is a perfect square, so you square root him and you just throw the I involved with him. X equals 3 plus or minus 2i by adding 3 over. And then you get your two roots, 3 plus 2i and 3 minus 2i. Yay, fun stuff. Got to do two more, right? Because there's some weird things that could happen. Every one that I want to do, weird things happen from here on out. Okay, so we're feeling pretty comfortable with what the process is. Once you get here, you have a quadratic situation. Set it equal to 0, solve for x. I could care less if you complete the square or if you use the quadratic formula, whatever you're more comfortable with. Let's do 17. What's wrong with him, though? Not in standard form. It's got to be equal to 0 first. So get him equal to 0, then graph him. Got him equal to 0. Should be 3 roots due to the fact that it's cubic. Got him graphed. Looks like at 2, I definitely have a rational root. So I will trace 2 to double check. Yes, he's a rational root. I've got 2 left over. That's good news because those other ones could either be rational or irrational or imaginary. Can they be imaginary? If you literally see them cross the x-axis, can they be imaginary? No way. I still want to know if they're rational or not, so I also have y equals 0 graphed. I want to see if they're rational so I don't have to do any of that quadratic formula. So second, calculate an intersection. I need the first curve, the second curve, and all I really have to do is find one of them so far, because if one of them is rational, then the other one's rational. This one's at 0.258, meow, 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 blah, 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 blah. No repeating pattern, no terminating, means he's irrational. So I got to go through the synthetic division process to find them. So, fun for us. Synthetically dividing by 2. 1, negative 10, 18, negative 4. Come on, pencil. Bringing this down, you get a 1. 2, then you negative 8. Negative 16, and a 2, and a 4. Remainder is 0. Good for me. This is quadratic now. He was cubic. You knocked him down a degree by dividing. So it's x squared minus 8x. I'm going to complete the square on him. Plus blank equals negative 2 plus blank. Since a is 1 and b is even. I'm telling you, though, there's some of them that you don't want to complete the square on because a won't be 1 or b won't be even. Use the quadratic formula then. This is a, this is b, and this is c when you use the quadratic formula. So fill in the blank. You take half your b value and square it. It'd be negative 4 squared. This guy factors to x minus 4, quantity squared. That's 14. That's good. Tells me since he's not a perfect square, that it's going to be irrational stuff. Square root both sides. Square root of 14 will not simplify either. So that says 4 down there with my bad handwriting. Sorry. One more of these. Excuse me. Let's graph this guy. How many zeros are possible? 5. Fifth degree. Let's graph this guy. This looks like negative 2 right here. Testing for me, since I don't have him actually punched in, is negative 2 a root? Nice. Question. Any multiplicity on that since it crosses the x-axis? Any multiplicity? No. Over here, looks like maybe right here at 1. There's a root there. 1 turned out to be a root. Yes or no? Yep. Any, let's check this out though. 1 answer, right, of 1 right there. How many blanks do you have left? 3. Bad news bears, because you only see 2 roots right here, meaning the others, since you don't see them, should be imaginary. Can you possibly have 3 imaginary answers, since they come in conjugate pairs? Imaginary answers have to come in multiples of 2. So that tells you that since this guy touches the x-axis but never crossed it, that root of 1 had to come how many times? Twice for sure. It could actually be all 4 times also, right? Because the multiplicity comes in an even amount. So it's either got to be there twice, it's got to be there 4 times, it's got to be 6 times. So I know right now that there's definitely 2 of them for sure. It could be that the other 2 are also 1, but there's only one way to figure that out, that is to synthetically divide. You know 3 roots for sure. It could be that this is 1 and this is 1 also, because that could be multiple of 4. So let's synthetically divide and see what the heck happens. 1, -2, -2, 8. Better be 6 guys in there. 4, 5, 6. Yes, there was. 1 comes down. Better get a remainder of 0. That's now 4th degree. You got to knock him down again by using one of the roots, which was a 1. I love synthetic division. I'll tell you what, it's better than long division. I don't know if you remember doing that or not, but that was no fun. Synthetic division's the way to go. This is now a 3rd degree. You got to knock him down again by using the other root of 1. Let's see here. -2, 1, 1, 0. You should be left with x squared minus 2x plus 1, and you want to let him know when that equals 0. You could complete the square on him. You could use the quadratic formula on him. Or, since we have a suspicion that they could actually be rational, maybe it factors also. Can you think of 2 numbers that multiply together to be 1 and add together to be a -2? There are only 2 numbers that multiply together to be 1. It's 1 times 1 or -1 times -1. Correct? Does this factor into x minus 1 times x minus 1 equaling 0. So x could equal 1 or 1 again. How many times was 1 a root? 4 times. So the real answer to this are the zeros is -2 and the zeros are 1. Then you throw in parentheses multiplicity of 4. Multiplicity, when you've got this point of tangency, happens in even amounts, either 2 times, 4 times, 6 times, etc. But there was only one way to know that this happened 4 times, was to go through the synthetic division process and actually see. You know for sure it had to be 2 times. Was it another 2 times? Was it another 2 times? So you had to go through that. Cool. Let's jump to 21 now. For 21 and 22, use the remainder theorem to find the remainder when f of x is divided by x minus c. Then use the factor theorem to determine whether it's a factor f of x. Same thing we did on the front page with a little bit of questions. So they want to know, like, first of all, what would you have to synthetically divide by? If you've got a polynomial that says x minus 2, you need to synthetically divide by 2. So let's see if 2 is a factor of this. I shouldn't say if 2 is the root of this, right? That's what they want to know. Does this cubic cross the x-axis at 2 or not? So you go through all this stuff. What did you get for a remainder? Should have got 8 for a remainder. Is 2 a root of this situation, yes or no? So then we write this down. X minus 2, my bad, as a quantity is not a factor of f of x because the remainder is not 0. X minus 2, whatever this dude was, is not a factor of f of x because the remainder is not 0. Now, if this remainder was 0, then you just say x minus 2 is a factor of f of x because the remainder is 0. And just be careful with those because 90% of the time we synthetically divide, we usually get a remainder of 0 because of the stuff we were doing before. We didn't know if this was a root or not. So that's what happened. Cool? Let's jump to 23 and 24. This is what we had to do before there were graphing calculators. It's like, how did you find those rational roots, dude? Like, if you didn't have a graphing calculator, it's like, how did you, like, not know you were supposed to divide by this or divide by that? So, there's this rational solutions test right here. It is kind of complicated until you do a few of them. It says, here's what you want to do. You list all the potential rational zeros of each polynomial function. So what happens is this cool little test says you got to know what P and Q are. P, you might want to write this down. P is the constant term factors. So like above these problems here, just say P equals the constant terms factors. And Q is the leading coefficient factors. Write that down real quick. Once you figure out all the P values and all the Q values, your possible rationals, so possible rational roots, are every combination of P over Q. Every single combination of P divided by Q. So I do this in 3 phases. First of all, I say P equals 2. P is the constant term, right? And that implies that really the P values I need is all of the factors of 2, right? So like every number, every combination of numbers that multiply together to be 2. Like what? 1 and 2. Anything else, though? Anything else? -1 and -2. So what you do is, instead of writing it all down like that, you think positively, right? Are 1 and 2 the only roots or factors of that positively? Throw a plus or minus involved with them. Plus or minus 1, plus or minus 2, right? Those are all the factors. You'd have had 1, 2, -1, and -2 are all the possible factors of P. Who's my Q value? It's the leading coefficient. Who's my leading coefficient? 6, right? I need all the factors of 6. So that implies I would definitely have plus or minus 1, right? Does 2 go into 6 evenly? So plus or minus 2. Does 3 go into 6 evenly? Yep. 4? Nope. 5? Nope. 6? Yes. So let me write this correctly first. Plus or minus 3 and plus or minus 6. Okay. That's it, right? Now it's time to put your answers. So, la 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 la, P over Q. Could be. I do every blue number one at a time over every green number, right? You will have plus or minus 1 over 1, which is plain old 1, right? 1 over 1, right? P over Q. Then I do plus or minus 1 over 2, which is 1/2, right? Then plus or minus 1 over 3, plus or minus 1 over 6. Haven't I used him up, right? I still got to go through the whole stinking process again. with 2 over every green number, but I'm not going to list anything twice. So I do plus or minus 2 over 1. Was 2 over 1 in this set? Yes or no? No. So 2 over 1, which is 2. Cool. 2 over 1. Then I do 2 over 2. What's 2 over 2 really reduced to? Do I have 1 in there already? So I've done him. Then I do 2 over 3. 2/3 was not in there, and you need to plus or minus 2/3. Then you do 2 over 6, which is really 1/3, is 1/3 listed already. So these are all the possible rational roots. Before graphing calculators, you had to figure these out. Then you had to substitute each one in one at a time and see if you got 0 back to see if they were really 0. So there's 2, 4, 6, 8, 10, 12 different things you'd have to substitute in and see if you got 0 back. Thank God for graphing calculators that we don't have to do that. So they say list all the potential rational zeros. Do not attempt to find the zeros, right? These are just, if you didn't have a graphing calculator, these are the numbers you'd check. Cool? Let's do 24. Who's the p-value? P is the constant term. He is 6, right? So all the factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Then the q value is the leading coefficient, which is -4. So who cares that he's negative? It's the same concept, the plus or minus all the multiples of 4. Plus or minus 1, plus or minus 2, and plus or minus 4. And the more you have, the more repeat stuff ends up happening when you do your P over Q, like a lot of stuff you'll have done already. But is everyone cool with all the multiples of P, all the multiples of Q, right? The next thing, P over Q. It's where you got to have yourself some sort of pattern to make sure you've done everything. I start with the red one and go over everybody. So plus or minus 1, plus or minus 1 over 2, and plus or minus 1 over 4. And lightly cross him out. Right? I've done red 1 over every blue number. Cool? Then I do red 2 over every blue number. So I need plus or minus 2 over 1, which I do not have yet. Plus or minus 2 over 2. 2 over 2 is 1, so I got him. Plus or minus 2 over 4, which is 1/2, I have him. Right? Done with you. Now all the 3's. Plus or minus 3 over 1, I don't have that. 3 over 2, I don't have that. And 3 over 4, I don't have that. One last guy left. See how many you still get. 6 over every single one of those guys. You get 6 over 1, which you do not have. 6 over 2, which is really 3, which you do have. And 6 over 4, which is really 3/2, which you already have. So this is all your possible rational solutions, roots. Then you'd substitute them in, see if they're really 0, and la 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 la. That would be a lot of fun. 2 more. 28 and 30. That's all I want to do. That's it. 28, nothing new. They just want to know, find all the roots again. So not a new concept. How many possible roots are there on 28? 4. Graph that guy. When you zoom 6 him, it should look like so. Possible rational roots. Take a guess for me. Where would you feel? It doesn't even necessarily look like any to some people. I'm going to at least try -1, see if that happens or not. Is -1 a rational root? Nice. How many blanks are left over? 3, meaning that those 3 roots that are left have to be rational, right? Because you can't have 3 irrational answers. Or I can definitely see this one here, and let's see if he's rational or not. You know it's not at 2 and it's not at 3, but intersect, see if that one's rational or not. When you intersected, did you get a repeating decimal or a terminating decimal? No. So this is irrational, meaning that there's got to be another irrational answer somewhere because they come in pairs, meaning someone's missing also. There better be multiplicity somewhere also. It sure as crap doesn't look like there's any multiplicity because multiplicity is where it touches the x-axis but does not cross it. That's a big fat clue that says zoom in. Zoom in to that. Zoom in. Go from -2 to 0 on your window and 1 to -1 on your window. Zoom in and see if there actually is any places of multiplicity. If you zoom in and change your x-min to -2 and your x-max to 0, y-min to -1 and y-max to +1, your graph will look like that at that same place right there. Cool. See this nice little point of tangency right there where it starts to come up and come back down, meaning -1 has multiplicity. So -1 was a root. Will it be another root? Yes or no? And then you already know about these other two. You check that one. It was irrational. Here's its irrational conjugate right there. So we need to find the other 2 roots by synthetic division. I had to zoom in to realize that, yep, that guy touches and doesn't cross, then it goes back down again, right? But at this point, it touched the x-axis and never crossed it because it came back up. So there was a multiple root at -1 there. So synthetic division time. 1, 0. Don't forget that there are no x cubes. Synthetically divide again by -1 since that was a multiple root. You can see that there are 2 roots still on your calculator, and you've already checked to see if they're rational or irrational, meaning factoring isn't going to do you one bit of good. You could do the quadratic formula or complete the square. One more. 30. Straight down from that. How many zeros possible? Trace. Let's graph him. That's right. 3x cubed is 2x squared minus 3x minus 2. Double check. Yes. Sweet. Looks like this. Definitely get a root right here probably. Trace 1. I like to put him in this position because that's like the third root. Like here's 3 roots right here. Looks like maybe there's some multiplicity right there because we're so zoomed out. So if I trace -1, let's see if that's happening. Yes. But did it happen twice? I need to zoom in. I can't tell if that's a point of tangency or not. I need to zoom in. So I'll check my window. X-min, I'm going to go to -2 to 0 again. Y-max, 1 to -1. Graph it. I didn't hit -1. So I'll need to do that to see that that really didn't happen. Oh, I got you. -1 to, let's go back. Okay. 1. Sorry. Is there multiplicity at that root of -1? Let me put that in so I could draw it. Here it is. Did that touch the x-axis or cross the x-axis? I crossed it. So is there a multiple root there of -1? Yes or no? It would look like this if there was. It should touch it but never cross it. Didn't it cross it? So -1 is not a multiple root. We also had a root of +1. How many roots left over? 1. Can it be imaginary? Imaginary roots come in pairs. Can it be imaginary? Can it be irrational? Irrational roots come in pairs. So it's got to be rational. So go to your calculator and calculate it. Second, calculate the intersection of that and y equals 0. First curve, second curve. I want to know where he's at. Come on, baby. Don't you get a repeating decimal of -0.6 repeating? What is that as a fraction? Not 2/3, but -2/3. Cool? The rest of this packet is your homework. Use the fact that rational roots can be whatever, irrationals come in pairs, and complex come in pairs to help you out.